Greetings, Gen Chem students. This is part C of the calorimetry online lab. And in part C, we're going to determine the specific heat capacity, SH, of a metal. And the metal is going to be copper metal. And you should have the protocol, which is on D2L, in front of you for part C, and read through this while you're watching this video. So the steps are: 1, mass the metal. The metal comes in this tube like this, and you'll pour it out onto a balance, and you would weigh the you get that mass. We'll talk about that later. And we'll add 40 mils of water to the calorimeter, then add we're going to heat the metal to 100 degrees C. Should have said that before. Add 40 mils of water to the calorimeter, add the hot metal to the calorimeter, stir until we get a new temperature, and do some calculations. So let's just set it up. So let's say we've measured the mass of the metal, and there would be the recorded mass. Now we're going to add 40 milliliters, put it down there, 40 millimeters of water, which is the same as 40 grams of water, to our calorimeter. And now we're going to add the hot metal, the metal that's been heated to 100 degrees C. Now, how are we going to heat it to 100 degrees C? We're going to have it in boiling water. And so, follow me. Here we have it in boiling water. We've had it in boiling water for about 5-10 minutes. And so we can assume that the copper metal in that tube is at the same temperature as the boiling water, which is 100 degrees C. Let me get another. And I'm going to take this, turn that off, and oops, got to be careful here, like that. And now we're going to take it over here and dump it quickly and directly into our calorimeter, and then put the top on, and then stir. Now, we had measured the temperature of the 40 mil of water that we put in there. The initial temperature was 20.5 degrees. All right, and the temperature is rising. It's up to 25 degrees C, and that makes sense because this very hot water, very hot metal at 100 degrees C, when it comes in contact with the cold water at 20 degrees C, its heat energy is going to leave the hot water and go into, leave the hot metal, and go into the surrounding water. So it's up to 28 degrees, and nope, it's at 27, and it has leveled off. It's not going up any further, so that gives us a final temperature of 27.0 degrees C, and what were 20.5 before, so our delta T for the water, H2O, is going to be the final temperature, 27, minus the initial temperature, 20, which would be 6.5 degrees C. All right? And that would go in here. So we take that and that temperature change, and from that we can calculate the amount of heat energy that left the copper metal. So the heat of the copper, Q, is going to be equal to minus Q of the water, like we've done in the previous two examples. And we had 40 grams of water in the calorimeter, 40 mils, times the heat capacity of water, 4.18 joules per gram per degree C, times the 6.5 degrees C. And that'll give you the Q, the heat of the copper metal. Now, to get the heat capacity of anything and everything is how much heat energy it absorbed or gave up, divided by its mass, divided by the temperature change of that substance. Well, we know Q, that's what will go in there. We calculated a Q. And the mass we have up here, and then the temperature change of the metal. Now, this is not the same as the temperature change of the water. The temperature change of the water started at 20 degrees C and ended at 27. What did the copper metal start at? 100 degrees C. So, and it ended at 27. So delta T of the copper is going to be T final, which was 27 degrees C, minus 100, which would be 73 degrees minus 73 degrees C. Minus 73 degrees C will be delta T of the copper. I'm crowding things in here. This isn't looking good. But that would be minus 73 degrees C. This is going to be a negative value from that calculation and the mass of the copper. Unfortunately, I didn't take the mass of the copper before I left the lab, and I don't have a balance here at home at the Eiler Chemistry Labs. So I'll sneak into the school under the cover of darkness, do a ninja thing, and mass that copper metal. And then once we have that, we'll have everything we need for calculating the specific heat capacity of the metal. And again, just like for parts A and B, what you should do now is to go to D2L and under online labs, find the show me video for part C calculations of the calorimetry lab. And we take these numbers and we show how you can do the calculations and get the numbers that you need, the information you need for your lab report. And that's the story.